So good evening, everybody. My name is Harry Helling. I'm the Executive Director of the Birch Aquarium at Scripps Institution of Oceanography. I'd like to welcome you all to the Jeffrey B. Graham Perspectives on Ocean Science Lecture Series. It is my great pleasure to introduce our speaker for this evening, Dr. Jules Jaffe. Jules is a research oceanographer with the Marine Physical Laboratory at Scripps Institution of Oceanography here at the University of California, San Diego. He is a fellow of the American Acoustical Society and a past recipient of a National Science Foundation Creativity Award. He's been at Scripps since 1988 and was previously an associate scientist at the Woods Hole Oceanographic Institution, where he played a pivotal role in the discovery of the wreckage of the Titanic. His research interests are broadly concerned with the use of the new technology for observing oceanic phenomena and the development of inverse techniques for their interpretation. His lab specializes in the development of a variety of underwater technology that ranges from miniature vehicles to underwater optical and acoustical instruments. His research is focused primarily on ocean ecology, but he has also worked in biomedical applications. In the realm of ocean ecology, several acoustic systems invented by Jaffe resulted in the first ever behavioral observations of zooplankton in situ. In addition, the small-scale distribution of phytoplankton, as mapped via an autonomously deployed imaging fluorometer, have provided unprecedented views of oceanic biota. A new generation of miniature sensor-equipped drifters that can acoustically network is also being considered in order to gain insights into coastal circulation and larval transport. Most recently, Jaffe has developed underwater microscopes for in situ characterization of micro and macroplankton. Please join me in welcoming Jules for his talk entitled Squid Pro Quo, Ocean Engagement for the Maker Generation. Welcome, Jules.
Okay, well, thank you very much. I think Harry took up most of my time, actually. So, I'll make it short. No, don't worry, not me. So, welcome all tonight to the Birch Aquarium. I think this is my third or fourth time over my more than 30-year career I've spoken to you, and it really is my delight to address our local community. And having lived in La Jolla, San Diego for 30 years, and this amazing scientific milieu around us has been a wonderful, wonderful experience that has really nurtured my career. And being here at Scripps, I must tell you that every organization has a kind of sociology and how people act to each other, and it's really fun to walk around this campus and just bump into all these world-famous scientists who are just so endearing and interesting. And one of the things I really like is they think my jokes are funny, so, All right, so let's get to business. Squid pro quo. So when Cheryl and I thought of this title, we thought it was rather apt based on the, quote, current situation. But we're not going to dwell on that. I often use humor as a way to relieve frustration. So let me just stop with that. And I thought we were very pro-squid as well. So what I want to talk to you today about is some of the frontiers that I see in what I'm doing. And it's not going to be like super technical. It's going to be more conceptual. And my style is as you can tell, more conversational and less pedantic. And I'm proud of that because ultimately, science is an endeavor by people, and I think it's important to portray it in a humanistic way. So here we are at Squid Pro Quo, a journey through recent developments in building less expensive and more capable instruments for ocean exploration. So for the first slide, I thought it'd be kind of fun to talk about my own history. And as a scientist, I'm always gone onto these websites. And I know these people because I see them at meetings. I've been doing this for 35. And they always have like a picture on their website of them like 20 years ago, And it doesn't look like them anymore. So not that I'm a competitive person, but I thought I could kind of one-up them. So here I am at the moment of conception. And I'm like, You zygotes out there, beat that, you know. So there I am. Actually, I was in Australia at the time, having a nice time. And then, you know, here's a baby picture. My dad and I used to go fishing together, and it was really what sort of brought me closer to oceanography. Here I am at the Miami Seaquarium, and you can see right away my GQ tendencies, you know, with the check shorts and the black socks and the black shoes, you know. And that's gone on till today, because you may not be aware, but last year we did South by Southwest. You may be familiar with that festival. They have 300,000 people. It's video and it's arts and it's music. And we had a panel on underwater robots. And I thought, what am I going to wear? And we study plankton, but I'm not going to talk much about that tonight. And I thought, you know, it's Texas. So we had done some scanning, three-dimensional scanning, which I'm not going to talk tonight. We're using optical coherence tomography. So I thought, let's scan a plankton and make it into a bolo tie. So that's what I'm wearing tonight, my plankton bolo tie. And you can see the fashionista in me just coming out. And then when I really got into oceanography, more so as a graduate student, and I don't think anybody ever really had a great time in graduate school. We try to make a congenial environment, but by the time you're ready to graduate, you're like, I'm done with this. I'm done with my advisor. I'm ready to move on. And we had a little 20-foot sloop in San Francisco Bay. I went to Berkeley. And there I am, relaxing and enjoying so much being on the water. So when I saw this advertisement in an electrical engineering journal for an image processor and someone who also enjoyed the ocean, it was the Woods Hole logo, I applied for that job and went and worked in Cape Cod for 5 years and did work with Ballard, although I'm not sure pivotal would be the word I would use. But I did help to design the system using principles of underwater optics and light propagation, taking advantage of work that was done here in the 60s and 70s by Siebert Duntley and his group. And then, of course, I'm not going to chronicle my last 30 years, but one of the things we love to do is to take students out on student cruises. Here I am with a group. We have a summer program every year. And as an educational institution, we feel it is our pleasure, duty, and often, you know, to inspire that next generation. So I just thought I'd show this from a few years ago. So I thought I'd tell you a little bit more about me and what drives me, really. And this won't be as funny as the moment of conception, as we would say. So you sound like you're laughing already. But for me, what really drives me is design. And when you think about design, I think about the creative process of designing something that has a functional use. And so one of the things that I love to do is to build furniture. So I'm going to just show you some of my furniture. And here are two pieces that I made. So on the left, you'll see a canyon table that basically I asked Walter Monk if he wanted to donate money to the Birch, and I would give him that table, and he did. And it's sitting in their Monk's house right now, and you can see that it's actually got what we call bathymetry. That's actually a three-dimensional map of Scripps Canyon underneath it. In a way, that was my donation. And on the right is a chair that I won. If you folks go to the San Diego County Fair, there's a woodworking show there. And this chair that I built actually won an award, honorable mention. But what I wanted to focus on here was not simply the end designs, but the design process, and emphasize that when you're involved in a creative activity, you have to have a high toleration for failure. Because a lot of times, if you're trying something that's really new, it's not going to work. But if you learn something in that process, then you can consider it progress. And so that table on the left I think everything I do takes me about 2 years, is a 2-year endeavor, and that's the third version of it. And the Z chair on the right, that's version 4.2. And some actually collapsed when I sat on them. But ultimately, that one never did, and I really think that it combines a figurative, sculptural, and functional aspect that I'm proud of. But the point of talking about it here is really to characterize my thinking about design. So in our case, we are designing instruments for oceanographers. So I need to know the physics of light propagation. I need to know the physics of acoustic propagation. I had a cursory understanding of mechanical engineering, and luckily I can rely on mechanical engineers. And as my electrical engineering and software skills have grown somewhat out of touch, I'm still thinking of ideas and can rely on wonderful people around me to help realize my dreams. But I just want to also show you that from an aesthetics point of view, which I enjoy, I'm just like an intense imaging person, we get wonderful images with our underwater microscopes. And here's one of them. So this was taken by an underwater microscope we had deployed from a ship about 15 kilometers west of San Diego and 20 meters deep. And it's a little jellyfish. And it just wandered right into the focal point. So there's no, and it's funny, when I show this sometimes, people are like, oh, that's computer graphics. And so it's sort of weird sociological thing for me that when I show someone a piece of reality, they think it's actually computer graphics. And so it's not. It's a real jellyfish. And we'll see things like this, 9 millimeters, so you're familiar with how big that would be. Something on the third of an inch. And it's a kind of organism that lives in the sea, a siphonophore. And I just marvel at the beauty of this. So my lab, they would say, well, if you want to make Jules really happy, just bring him good pictures. And so it's true to some extent. Years ago, we decided to tow one of our microscopes around the Cayman Islands, much to the admonition of some of my colleagues. And it worked great. And what's really cool about this picture is this is an organism that if you captured it in a net, you would just squish it up and you'd never see. And there was some seaweed around it. And I'm not sure exactly how big it is, but I think it's on the order of centimeters. And then this last picture that I wanted to show you is a coral that was taken in my lab. And the story here could easily take the next 40 minutes or however much time I have left, because this was funded by the Keck Foundation. And I did want to highlight the important role that philanthropy plays in science and creativity, because we had gone through a fairly rigorous process of UCSD, and then the Keck Foundation asked us for letters, and then they liked our proposal, and then they did a site visit. And at the end of all of that, they actually gave us $1 million with no strings attached. And what I did was looked around. We had proposed microscopes, that there was no diver handheld microscopes that people were using at the time. And I thought, well, let's use that Keck money to build the world's first or modern underwater diver handheld microscope. And Tally Tribitz on the right and Andy Mullen on the left. Andy was a student, Tally was a postdoc. We got this picture of coral fluorescence. So if you're familiar with fluorescence, you shine light in one color and it glows in another color. And what's really cool about this is you can actually see the little tiny red spots in the fingers of this coral polyp, which are 10-micron plants, which we call symbionts, that live inside of that coral tentacle. And I love the idea of teaching people about science by showing them pictures. In this picture, we got a lot of mileage out of it. It was on the front page of a journal called Physics Today. The Keck Foundation put it on their front page, and my development people will love me forever for that. And I just think it's an amazing, amazing picture. But we don't have more time to talk about that story. What I'd want to talk about is motivation. And here you can see me, Harry wanted to know tonight if I was going to come as a plankton. But Many years ago, my very close friend, who's now department chair, Peter Franks, and I did a comedy routine called The 2,000-Year-Old Plankton, which was a sort of emulation of an old Mel Brooks routine. And we had 250 people, and the great thing about that, actually, aside from the fact that people laughed, was the students could really, again, see the humanistic aspect of our lives. And Peter's a wonderful player. So for me, last year at South by Southwest, I tried to encapsulate my personal, professional goals. And I decided to make it fairly simple: scientific discovery, technical innovation, and outreach and education. And in the best of all worlds, those three things could be combined. And most of the time I can do that. But what about inspiration? What is it that inspires me to do what I want to do? And I just wanted to show these two snippets. So I am fascinated with the concept of dimensionality. And as a student and electron microscopist in cryo-electron microscopy in the 70s, became very interested in how we take two-dimensional images around three-dimensional objects and convert that into a three-dimensional object. And there's this very old book called Flatland by A. Square, of course. And you can see it was 7 shillings and 6 pence. And Edward Abbott wrote this book about what it would be like to be a two-dimensional creature that went to live in a one-dimensional world. So perspective is important to me. I enjoy sensory physiology and understanding our world about us from our sensory physiological point of view. And then on the right is, nobody can either, has ever, nor may not ever come close to Leonardo. And this is one of his inventions, and his artistry, and the descriptive aspect of his life in describing nature and trying to understand it. And we talk about biomimicry today. Leonardo had all these winged inventions that he had hoped to promote human flight. And he had advanced amazing things. So as a techie kind of guy, I kind of like to sit on the edge of where the technology is going. And I try to look at the oceanography around me and imagine how that technology could be used to further understanding the marine world and advancing ocean exploration. So what I'm showing here are essentially are 3 areas. On the upper left, advancing and ever more inexpensive computer technology. On the upper right, artificial intelligence with neural nets. And in the middle, on the bottom, is DNA. And in the background, there were my little robots. You're going to learn more about those. And by the way, I did that video. So these are 3 areas that I see as really transforming our interest in environmental science. But tonight, I'm just going to talk about, and we're actually working with artificial intelligence. And even though I'm not a, quote, DNA person, we have resources on campus, and there's a whole movement now about scooping up water and measuring environmental DNA. And what might that tell us about creatures that we were not lucky enough to see? So tonight I'm going to talk about advancing and ever more inexpensive computer technology. And I wanted to highlight this, quote, maker generation. And here I have a picture of Phil Bresnahan. I was actually on his thesis committee, and he has developed a smart fin. Some people may be aware of this. And the idea is, people are out in the ocean, and if we can get them to sense environmental variables in their recreational activities, we'll learn, and they'll feel good that they're contributing to science. And Phil was recently made the director of a new lab here at Scripps Oceanography called the Makerspace. And what you're seeing here is, it opened a year ago, so maybe not that recent. There's all this stuff that we can do now, 3-dimensional printing, and it's become so much more accessible. I was talking a little while ago about how 20 years ago, we bought a digital camera for $35,000. And today, my students, which you'll see in the next few slides, are buying these cameras for $100 that do almost the same thing, maybe even better, and can be used inexpensively in a next generation of ocean instruments. And so we're excited about this Maker Lab. And this is a widespread phenomenon. Last couple of years ago, I was invited to give a talk at Yale, and I've been to Princeton and a few other places. And this maker generation is really taking off because it helps, the kids really like it. I mean, I run a summer program for undergraduates, and the most enthusiastic students I saw in the summer program were the ones that were actually making things. And so I'm excited about them being excited, and as an educator, having active participation is something that I love to endorse. But for me, it all starts with science. Because, when I make a chair, I want somebody to sit in it. So when I make a robot, I want to discover something about the world around us. And so we're going to go through a few different areas of scientific inquiry and show you how this maker generation has the potential to revolutionize how we're exploring the ocean. So the first thing I want to talk about is, can we improve how we monitor the health and recovery of marine protected areas? And this is something really near and dear to the La Jolla community. One of my favorite walks is near the Cove, and you can walk along the dirt trail there that goes over to that little bridge that goes onto the other side. And looking down the coast, this is a picture I took with my iPhone. You can see this Conserving California Coastal Treasures. And what we're showing here in blue and also in red are areas that are marine conservation areas. So I'm certainly not against people catching fish. I like to eat fish, but if you ate the last fish, there's not going to be any more fish. So we decided to set aside these marine protected areas. There are many sad stories about species in our coastal areas that have been depleted. And the idea was to help isolate them from exploitation and create sort of this resource where the fish could grow up and they could have babies, and then the babies would go maybe outside of that area and we could fish them. And it's just sort of like farming by encouraging conservation. So about 6 or 7 years ago, I thought it would be fun to try new technologies. I had been focused on using advanced fish finders, which we're not going to talk about today, but maybe just listening. What can we learn about underwater marine life? But tonight I want to alert you to the possibility that fish do a lot of talking underwater. And might we be able to understand how those marine protected areas are recovering by simply listening? And so that's the idea. Here I'm highlighting one of my students, Camille Pagniello. And here you're seeing her very beautiful graphic of putting these underwater microphones, which we call hydrophones, in the water to listen to the sounds of the fish, right? So imagine you go to an auditorium and everybody's talking. Could you estimate the size of the crowd by the level of audio? And so we started this project. We applied to the Sea Grant, local Sea Grant, and they said, yeah, we'll give you guys money. And by the way, we're really interested because we'd like to have less expensive ways to monitor fish populations. The way they do it now is with divers. And if you're a diver, you get an hour and you do a visual survey, and then maybe you come back the next day. But if you could put underwater microphones in the water and listen 24/7, you could then have much denser sampling, given the possibility that the fish would be making sounds. So what we also decided to do, so here's a kelp forest. We talked about that before. This is a picture of Camille's rig, and you see a cinder block there with a test target on it, which was used for color correction. And so here are the bad joke. preaching to the choir. But here we see the 19 species of fish. Soniferous means sonar or sounds that can actually vocalize. And the idea was, could we listen to them? And hopefully, as these marine protected areas recovered, the population of fish would increase, and we'd be hearing more and more of their vocalizations. And there's also some understanding or misunderstanding about whether they only vocalize when they're spawning, or do they not vocalize? And so we just put a hydrophone on Scripps Pier. So here's how little we know. I said to one of my engineers, let's just put a microphone on the pier. We have these microscopes on the pier. You can go on my website and see all the plankton that are out there. Many look like my bolo tie. And we started hearing these fish. And then they came, Camille and this other postdoc said, what do you mean you're hearing fish on the pier? It's not spawning season. I'm like, well, I don't know what's going on out there, but they're making a lot of noise, you know? And they came to me, I was like, wow, they're making a lot of noise. So there is evidence that these fish are vocalizing. So I just want to share with you two sounds on the left. It's sort of not a cute fish, kind of miserable looking fish, you know. But it makes this wonderful sound, which it's sort of, and you're going to hear it, you're going to think, well, is that like feedback on your amplifier or what? And the answer is no. That's the sound of the fish. If I can get this going here. Go back there. Here we go. Now how it holds that tone, you know, is unknown to me. I mean, if you're familiar with jazz, Rasa and Roland Kirk used to be able to play a continuous tone, but the fish outdid him, you know? And then what people are more familiar with, because it's actually a good eating fish, was this rockfish. So here we're going to listen to the Sebastes. So I just wanted to give you a feeling for what these fish kind of sound like. And they do make these sounds. So we invented an underwater system because we wanted to figure out which fish was making which sound. And the idea would be to take a picture of the fish and to have the microphones able to tell the position of the fish. So kind of the analogy I would use where we can hear with our two ears and we can stereoscopically localize direction. If you have more than two ears, like 4 hydrophones, you can not just, you can do more than direction, you can actually identify location. So what you're seeing here is an underwater camera and the underwater microphones and the battery pack. And Camille did an amazing job putting this together with some assistance from engineers in my group. And we were actually able to get lots of sounds. And she's now working on figuring out where the fish were using the hydrophones to localize it. So I don't have that data. But what I wanted to highlight was sometimes the unseen consequences of inventing technology. So we put these cameras out. We thought, well, they're pretty good cameras. They're these Sona 7 alphas. And we think they're sensitive enough to see the fish. But we were totally surprised when we found out that we could not only see the fish, but we could see them a half an hour before sunrise in the kelp forest. And we could also see them a half an hour after sunset in the kelp forest. And as a person who has spent a lot of time listening to marine biology, a lot happens at dusk and dawn. And it's called crepuscular, that's a fancy word. And so the predators come out and the prey are out. And the prey are hungry because they've been in avoiding being seen. And the predators come out because they're hungry. And there's a huge amount of action in these crepuscular times. And what you're seeing here are these images of the fish that Camille took at times where we thought it was totally inaccessible to see them. So not only is it interesting to listen to the fish, but also behavioral observations with low-light cameras, which do not need artificial lighting, right? So right now, this rather bright light is in my face, but I'm trying to act natural. I think I'm doing okay. But if you flash a strobe at a fish, get me out of here. But these cameras are capable of recording really amazing images with no light other than ambient light. So we go to a local expert. That's the thing about being heretoscripts, Ed Parnell. Ed, he's like, these are amazing. I'm going to use them for my studies. So I just want to point out the sort of development of things which are somewhat unanticipated. So what about new instruments to explore seafloor habitats as my second topic? So this story starts in 2017 with a postdoc that was in my colleague Stu Sandin's lab, Maya DeVries, got a PhD at Berkeley, came down here for a postdoc, and she's really interested in what's happening inside the coral reef. So when you see a coral reef, you're just seeing the top of it. But 80% of the productivity that's happening inside coral reefs is happening inside the coral reef in these cryptic environments. So how do we explore those? And here Maya is now an assistant professor at San Jose State, good for Maya, is putting a GoPro into one of these underwater landscapes. But in the process of that, we also started talking with Stu Sandin, who you may know, who is one of the principal investigators in the 100 Island Challenge, along with Jen Smith. And what this picture shows, other than Stu, is a coral, and on top of it, you see that square. Okay, so that square is a target. And what they do is they take their cameras and they fly around over these squares, and they want the target because they want to know how far away the coral is. And they do something very fancy called structure for motion, which allows them to get three-dimensional data. And Stu said, you know, these targets are okay, but maybe, you know, and okay, and then here is actually the way they use them. So they have 110 meter by 10 meter places where they're actually studying. And Stuart had this really great idea of maybe you could build me a target that actually had a sensor package. So when I flew over it, the QR code would tell me what the temperature was, what the orientation is, what the depth is, what the tilt was. I was like, I don't have to invent everything. If he thought of a cool thing and we wanted to work with me to build it, I was like, great, here's the scientist, here's the application. So great story. The Schmidt Institute funded this with their end of year funds, and we're going to be meeting this week to talk more about that. Okay, so measuring underwater currents. So here's my student, Pichaya Lertvilai from Thailand. And as part of this thing with Maya, we said, well, what about measuring underwater currents? People doing it today with sonar, and the units are sort of $8,000. What about if we could just use a video camera and track particles? So the water is filled with little particles, even though sometimes you don't see them. And so Pichaya put this video camera together with stereoscopic vision. And here you're seeing a left and a right field of view. And what you'll see now is the flow of water going through this. It's going in one direction. Now it'll come back and go in the other direction. And basically, he was able to show that we could get virtually the same results as the sonar system for a tenth the price. And then what I, of course, am somewhat enchanted with, as we've talked about already, was Leonardo. And Leonardo spent a lot of time wondering about turbulence. And turbulence is almost a religion in oceanography. There's this thing called the Navier-Stokes equation, and it's sort of, you solve this thing, and then you can figure everything out. But the thing is not easy to understand to begin with. And then when you solve it, you're only solving it under certain conditions. So what I wanted to intrigue you with is this idea that we're seeing turbulence in this video. That means the particles are not all moving together. And we're working on some ideas to build a turbulence meter from this particle velocimeter. And that's Leonardo's picture of turbulence up in the upper right. Okay, moving along here, what I wanted to highlight that Pichaya actually decided he was going to build his own underwater video microscope. And sadly, one of our colleagues passed away many years ago, Mia Tegner, in a diving accident. And someone created a fund. And Pichaya was able to get $1,000 from the Mia Tegner Memorial Fund. And on his own, built this great underwater camera. There's two of them you'll see there. Took them to Hawaii. And here you're seeing the video that he took at night of these plankton coming up. They'll come up out of the sediment at night, which we understand very little. And I got an email this morning from Jonathan Shuren, who's a biology professor who studies lakes up in the Sierras. And we actually lent him this camera. And he said, wow, this thing is going to change my world. I love it. So ushering new students is what we're proud to do. So a little bit on public awareness. Years ago, not very many years ago, I was approached by a foundation. And of course, plastics in the ocean is a huge problem. So I thought, well, could we build a home kit? Increase people's knowledge of how much plastic they're dumping in the ocean if you use a facial scrub. So buy stuff in CVS. Use a solvent. Dissolve away the medium that the scrub is. And then use a microscope to see the plastic microparticles that are in that scrub. Because bringing something home is a way of transitioning it from a thing that's in the newspaper to a thing that's in part of your life. And the students were actually successful in taking several cosmetic products, and you see there on the left, using like an iPhone microscope, you could actually see those particles. So we're working with Parley Foundation that's interested in creating citizen science activities on their website. They're funded by Adidas. And I find this to be a wonderful use of our students and a way of publicizing to the public the need for conservation. So, lastly and leastly, I don't have a huge amount of time, is to make-believe plankton, to stimulate being transported by ocean currents. And the quest for better ocean information, Walter Monk, who I had the wonderful honor, privilege, and enjoyed meeting him and spending time with him, said, you know, the 20th century is going to be remembered for undersampling the ocean. So let's go back to the world of A square, where the creature wants to understand what the dimensionality of its world is. And the ocean is a three-dimensional dynamic environment, which is changing. And so I had this idea that we could build multiple vehicles to actually sample different places in space and time. But this all started in 2001. My friend Simon Levin, who's one of the preeminent mathematical ecologists in the world, he's won the Kyoto Prize, he's a National Academy member, and he's a super nice guy, invited me to a meeting, and I met Jane Lipchenko, who you may know was the head of NOAA for many years. And their question was, can we measure water currents to help figure out where to put these marine protected areas? And then a few years later, maybe not so few, my friend and colleague Peter Frank said, can we measure a swarm of plankton trajectories? So this was a development effort that sort of took over a long period of time. And I thought, well, let's build little robots and we'll just track them in 3D and they can tell us where the plankton would have gone. And here you see a model of that. And of course, Peter is always a bit of humor. He decided they looked a lot like the Minions. And we were fortunate because what happened in 2009, there was a huge stimulus. And they funded us. They had a little bit more money than they thought they would have, this National Science Foundation. The project was well reviewed, and they thought, you know, somebody should really try to build these kinds of things. I'm not going to go too into the details. What I'm showing here is that actual cylinder expands to change its buoyancy. When, like, if you're a diver, you know, you inflate your buoyancy compensator. When you go down, it gets squished, and you don't want to keep going down, so you inflate it, and when you inflate it, it brings you up. And so we were able to make almost a couple of dozen of these. And here you see a navigation net that we deployed first, which allowed us to track them in 3D. And this is Eric Ornstein, who's a postdoc in my group. It kind of helps if you like paddling, whatever it is, stage 5 rapids in your kayak, and you don't mind being out on a small boat for hours. And here's putting these navigation buoys in. And then the next video shows our little floats, which I really love the idea, which I call the autonomous underwater explorers. And here they are programming these little robots. Well, we used to call them floats, but then robots became sexy. So we just said, okay, now you're robots. And all of a sudden everybody's like, wow, robots, that's cool, And so here you see you got to shake the bubbles off, and you can put them in the water. Oh, there's actually a soundtrack, thank you. And we put a bunch of these in. And I really don't have time. That paper we wrote it was in Nature Communications, is now in the top 1% of papers from 2017. Academicians, we like to keep score about this stuff. So like, oh, I'm really cool. I got them in like the top 1% of papers in 2017. But Jessica Garwood took these out off of Mission Bay. She'd recently graduated. And the idea was to look at transport of these floats. So these little stars are the floats. Here they go. Whoa, we're going to be surfing any second. There we go. So without going too deeply into the science, there's a way that we wonder if animals can be transported shoreward. And it's been kind of fun because actually what's happened is major, museums have picked this up. And people think, oh, Jaffe goes around the world trying to sell us stuff. It's like, no, not really. I mean, they get in touch with me. We were working with Museum of Natural History in New York City on a exhibit which had been virtual microscopes, reality, three-dimensional. And sadly, the philanthropist was unwilling to fund that. But then they said, oh, you're building these robots. You should talk to the people. Ray Dalio has funded this Unseen Oceans, and they said, yeah, well, we want your robots in our exhibit. So here I am being quoted. I love the experience of discovery when you know you're literally the first person on the planet to observe something. And then I got an email from the London Museum of Science last year, and they said, we're doing this show on autonomous vehicles, land, air, and sea, and we'd like to include those. So it was like, great, I get a free trip to London. And there's an online video of me talking about these things. It was like, pretty good. So I just wanted to end on future robot designs, because we're not finished. In fact, you might think we're getting started. If you looked at technology now that's 20 years old, you would think, wow, that was what we did then. And what we're doing now, maybe in 20 years, we'll have the same perspective. So one of the things I'm just fascinated with would be to build a little robot that you could put in a fish tank. And you could actually have your iPhone app somehow communicate to it optically, sonically. And as it swam around, you could guide its course and see it on your computer screen. And I just think that would be so cool. Last year we had a master's student looking at optical communication. It turned out we had really great images from optical communication. Another idea I call the Basking Shark Bot. So plankton are very sensitive to movement, and so the largest organisms in the sea, the blue whale and the largest fish, actually eat plankton. And the basking shark is one such animal. And how does it do that? It creates a very small hydrodynamic disturbance. So might we build an underwater vehicle that was kind of like the basking shark, that would allow us to swim around and actually see little plankton in the water? And not just one vehicle. I'd like to have a dozen or 24 or 100. And then the last one I wanted to talk about very briefly now, because I'm a little bit over, is a new vehicle that I'm imagining called a smart origami vehicle. So what do we mean by smart? So one of the problems with our vehicles, they go down, they get compressed, they change their buoyancy. If the vehicle could know its own buoyancy, it could then adjust it to stay at a certain density level. And the other thing is that we want them to be deployable and get to where they go fast. But once they get there, we want them to expand their size so they would be more susceptible to being propelled by underwater currents. So I reached out to folks at the Jet Propulsion Lab, and I don't know if you folks are into the PBS Nova series, but there's an amazing video on Origami, and the people at JPL have limited load capability in their launch vehicles, and they've developed this technology to unfold things. So they're interested, I'm interested, I don't know what's going to happen with it. But this is sort of my pet project, and maybe we'll start building these. And last, I just wanted to touch on a future vision for the Birch and talk about how excited I am about the future. As Harry described, this facility is antiquated and needs to be replaced, and we want to grow it. And the wonderful thing that we do here, of course, is to bring students in for all these activities. And I'm particularly excited about the Education Center and how we can take this maker technology in the context of science discovery, which is being guided by we scientists. We don't want them just building like a thing. We want a thing that can teach us more about what's happening in the ocean. And hopefully we'll be able to fulfill that dream. So that's all I have to say. Thank you so much for coming tonight. Thank you very, very much. A question? Yes?
As a long-term scuba diver, as many other people here may be, I'm fascinated with the sounds of the fish, but are the sounds that they're making, are they within the human auditory range, or are most of them different?
No, actually, so the ones that I played for you today, it turns out we're in pretty good shape to hear the fish, because some of the sounds are really low, actually, and that's why they travel really, really far. If you make a high-frequency sound, it doesn't go very far. So I think that's why they actually make low-frequency sounds. And yes, they are within our audible range, and it's sort of interesting because when you dive, if you're not on a rebreather, you're actually making quite a bit of noise. Don't take it personally. All you scuba divers. So that's like an unseen, part of the ocean. So putting these microphones in and getting everybody out of there, I think we have a lot to learn. But thank you very much for your question. Anyone else?
I wonder if you would comment on how serious the plastic situation is in the oceans. Do you have an opinion?
Well, of course I have an opinion. Well, I think the dimension, so I think everybody heard the question. So the question is, how serious is the plastic situation? So the dimensionality of that is sociological and physiological. So very close friends of ours were just in Fiji. And as you know, a lot of these states or countries that don't have a lot of produce or capability for industry rely on ecotourism. And when all this stuff gets washed up on the beach, people don't want to go there anymore. So it's just so sad to me, it breaks my heart to see the prevalence of ecotourism being threatened by all these plastics. So that's the first part of the plastic problem. The second part of the plastic problem, if you've seen it, and I watch the same shows on as most of us, and you see these poor albatrosses that are going to their islands, and the carcasses are just filled with plastics. Yeah, and it's just awful. And I don't. It's a bit sad about what I do that when we increase our tools of discovery, the potential is that we're learning about the degradation of the ecosystem. But our hope is that someday, sometime, someone will look out and go, we want to try to fix that. And the knowledge of what's happening would hopefully drive the promotion of policies that are more eco-friendly. And I could talk about that for another 10 minutes, but I would rather thank you for your question very much. My pleasure. Yes, we have a person over there.
So you were talking about the underwater microscopes that divers are using. Are they commercially available or are they strictly for research?
Okay, so what we're gonna do is we don't sell them, first of all. I mean, I wouldn't mind making some money off them, but we're not like set up for that. What we're gonna do is partner with this organization Parley and produce a citizen science kit that would allow people, K to gray, look at the color of my hair, to actually build these things, and you'll be able to take them out. And they're like, all the components are like, they're not ridiculously cheap, but that scope that I showed you that Pichaya built was around $500. So the answer is I don't know of any commercial products, and our interest is in making more citizen science available. And at that point, because the macro zooms don't really get you to the resolution that we're achieving. So the answer is they won't be commercially available, but we're interested in, and by the way, we're actually building 2 new microscopes, one to see bacteria, which are 1 micron particles, and another to look at coral health. And they're coming about now, and we're hoping to get more information about physiology of corals, as long as we're talking about microscopes. So I'm happy to stay here all night. Do we have any more questions? I'm not resistant to more questions. Okay.
Thank you, Jules. As you know, Scripps has been very important in developing new breakthroughs. Ravel's promotion of the imaging of the sea bottom that gave us a breakthrough in plate tectonics, and the ability to discover by keeling the measurement of parts per million of carbon that gave us the ability to see what's going on in depth in climate studies. We don't know much about what's happening with the currents in the ocean and the effect that's having on on climate change. Could your discoveries give us that kind of a breakthrough in imaging how currents are moving in the ocean?
Well, the plan would be to start small, and so the global answer, of course, is yes. And you're probably aware that the Argo program itself is, I think they surface every 10 days, and they're giving us information over much larger scales. Our start was actually just here off La Jolla, looking at things that are called sub-mesoscale eddies, which are on the order of 5 to 10 kilometers. And so, yeah, I mean, there are fleets of underwater vehicles that are going with the flow, coming to the surface, telling us where they are. There's a DARPA program thinking about building 50,000 vehicles. And so I think the potential is certainly there. And hopefully the general question of having higher space-time sampling of not only currents, but plankton. And the example I used for the British Museum of Science in the context of plankton, let's say we're measuring a chemical and it goes like this, but we measure it here and we measure it there. We never knew where it changed its concentration. So perhaps it'd be fun to try.
Well, it just happens that I've been worrying lately about the recycling that I do. And I think the public needs some guidance on, maybe size and things that are, you floss your teeth with these sharp things. And I haven't been throwing them in the recycle because I worry about what might happen with the animals. So in other words, I wish the public could be informed some way.
About recycling, yeah, sure. I mean, I certainly appreciate your attitude. It's not necessarily a marine science question, but and it's not a criticism. But I think what we're seeing, there's been a kind of revolution brewing about straws, and we're getting away from them. And I've noticed a lot of the takeout places have been using wooden, forks and spoons and things like that. And hopefully we'll be able to think of one of our colleagues here, Dimitri Dehan, is interested in developing, biodegradable utensils. And I think if there was more of a push for that, water's a great solvent. And perhaps we can make progress in those areas as well. But of course, we're all concerned about those things. And thank you for your question. And thank you very much. Thank you very much.